It's Monday again. Mike and I are down here at the shed. Mike got here a little bit before me this week, and he has started stripping down an old play field that he has.
This is Matahari.
Matahari. So anyway, he's pulling all the stuff off of that. Of course, we have our 8-ball deluxe table. I pre-recorded a little something earlier this morning looking at the schematics for installing the solenoid driver board on our little board here, and I'm coming into a completely dark place. But right there you can see the SCR that drives the light string, and we're going to be hooking that up today and trying to get that working. That's my big to-do on the list. Last week, sometime last week, I came in and soldered on the wires for the switches for these pop bumpers, and one of them is now working, but the other one isn't. So I need to troubleshoot that also. And then, of course, we had the little problem with the lights not working quite right, and it occurred to me that we have some more LED strings, and we can just unplug this wire right there, plug in a couple other LED strings to see whether the problem is in the LEDs themselves or in my code. So place your bets. Okay, I wanted to just explain a little bit about what we're going to have to do today to get the solenoid driver board, auxiliary solenoid driver board hooked up. So if you look over here, this dotted line here represents, and I'm not going to draw around the whole thing, but you know, that dotted line box there represents the solenoid expansion board that is mounted on the underside of the play field. Now, when we stripped the play field and moved all this stuff over, we did not reattach these lines right over here. And so those need to be reconnected. Now, this SCR is the SCR that's on the light driver board. It's actually, I believe, let's see here, pin 11. I think it's this SCR right here, if I'm not mistaken. But pin 11 right here on J3 of the light driver board goes to the auxiliary expansion board. Well, the light driver board no longer exists, so we have to duplicate this SCR's output so that we can switch this light driver board. And if you look over here, you'll see that this SCR actually drives a real light bulb. That light bulb is the physical load that causes the SCR to draw enough current to stay energized. And then they just tap off of that, activate a light emitting diode through a photoisolator that activates the actual relay that does the switching of the solenoids. So we need to duplicate this so that we can activate this and switch the solenoids. Now let me pull up a copy of our schematic. So this is our schematic. The output, and I can no longer mark this, but the output from our computer labeled relay comes in and switches this SCR on and off whenever it detects that the SCR or the solenoid driver needs to be activated. And we drive that out on pin 11 of a 28-pin connector, just like the pin 11 on the original 28-pin connector. So we will take the old cable that we've stripped out, and we will plug it back in here and reconnect this up to the expander board right here. So that's going to get connected right there. So that'll become our SCR connecting up to pin 2 of this board, and we will have to reattach the switched illumination bus and put a light bulb across that and that should make that circuit work. So that should be all we have to do, assuming that the software is working correctly, which is a big assumption in my software. But if the software is working correctly, then the switched illumination bus should power this circuit, and whenever we drive a signal out to it, it should turn on. At some point in the future, we'll probably look at replacing that physical light bulb with just a resistor. All we need is an adequate load. I just don't know what the resistance of those bulbs needs to be. It's probably something down in the 20 ohm range or something like that. But we'd have to have a big enough resistor that it wouldn't burn out when it's energized. So that's it. That's one of the things we will probably be working on down at the shed today. Okay, just to show you guys, there's the light cable that we extracted from the old pinball table, and I have removed this one connector and one wire from that bundle, and that's going to be hooked up to the board to drive that solenoid expander. So I'm up here at the box. I have a blue wire coming out of the bottom, this little thin blue wire, which is the wire that was on that connector, and I have plugged it into the cord. Excuse me, plugged it into the card, and I looked up the wire. The other side of this that powers this is the switched illumination bus, which comes from this connector right here, and it's a blue wire dead in the center of the thing. And I came up here and I found these two thick blue wires that have been disconnected, and I'm assuming that one of those is the power coming in for the switched illumination bus, and the other one is a redundant or outgoing line that I can remove. But I'm going to get my meter out, I'm going to power the machine up, and I'm going to ohm those out to see, I'm going to meter them out to see which one of those has 6.5 volts on them. And then I will hook up that little blue wire to a light bulb to that, turn the machine on, and see if I get any flashing. And if I do, then I know we got our SCR working, and I can go ahead and hook it up to the relay driver board, which is up there in that corner right there. So we'll be back. Okay.
Your test program is running.
Yeah, it is. I need to take that out of there. Okay. You there?
Quit talking and start talking.
Nothing on that wire. And that has 7.75 volts, so that short wire is the wire we need to do our job. Okay, I have wired a light bulb between the switched illumination bulb power and the output of the SCR on my board. And if everything is working correctly, when I plug this thing in, it should, when it goes through its reset, flash that light a couple of times as it's resetting the solenoids. So let's hope for the best. I've never tested this circuit. I never even breadboarded it. So look at that. The light is on constantly. But that may happen, and after it resets, it might turn off. I don't know. We'll see.
Ball Deluxe, 5 ball.
You may have to start a game.
Shouldn't have to.
Chalk up.
Knock some of the targets down.
No, because that should have already reset. It should have gone through the thing now.
So this should be off now.
My belief is it should be off. They wouldn't run the solenoid driver activated all the time. Again, this could be a code issue. I may not be firing the SCR correctly. What this is saying is that the SCR is turned on right now. So, not what I was hoping for, but we'll troubleshoot it out and see what's happening. The process of re-downloading some code into my processor. I took the processor off, I checked the circuitry, it all looks good, everything looks like it's wired correctly. I looked at the code, I couldn't find any bugs in it or anything that I could spot. So I basically commented out the part of the code that turns this light on, and I just set it to always turn it off. If that doesn't change it, I'm going to go modify that code so that it always turns it on. If none of that changes it, then I know that I have a problem on the output somewhere and not in the code. The code couldn't possibly control it. But we'll see. So right now the code that I've just downloaded in there should excuse me, I'm just looking to see if it downloaded okay. Yep, it downloaded okay. So the code that's in there should turn the light off if it works correctly. So I'm going to quickly plug this in. And if you look at the bulb is turned off. That's amazing. So now I'm going to modify the code so it turns it on all the time. And I'm assuming, oh look, I got the regular code back in, so the lights are flashing and stuff again. Okay, so I'm uploading the code already, and that code should turn that light on. Look at that. So I can obviously control that SCR and turn the light off and on, and I have some code bug that is causing the light
To stay on.
to stay on all the time. That's a wonderful thing to know. Okay, so good news. We've made progress. And actually, I think I'm going to go from here. I'm not going to debug the code right now. I'm actually going to go through the process now that I know I can control it off and on with my board. There's nothing to stop me from wiring it all up so that I can control the solenoid expansion board. So we'll see how that works. Okay, so what I have here, I've just pulled a wire that goes to the relay expansion board down to here, and this is the wire that I just had hooked up to the light. I'm going to connect these together. I'm going to connect the light bulb onto that. I'm going to mount the light bulb right down here somewhere, and then I'm going to have to bring power, these two power wires, I'm going to hook them through this fuse, they were originally hooked up, and then take the output of the fuse and bring that wire down to the other side of the light, and that should complete the circuit. I think I'm going to do that off camera because I'm not sure you'd be able to see me working in there anyway, but I'll bring you back when I get it all done. Okay, I just wanted to show you guys that I hooked up the blue wire that we had power coming from to this fuse. The output of the fuse is hooked to this blue wire, which now comes down, goes across here, and runs to that board, so that should be powering that board. The green wire I've added, that's going to come up here, and I don't know if you can see it under here, but it's still dangling here, and I'm going to hook it up to that light bulb right there when I get a chance. But I just noticed something while I was down here doing this wiring. We never hooked up the wires to the solenoid that kicks the ball out. So while I've got this in such a convenient position to work on, I'm going to solder that on right now. Finished the wiring. I haven't found the software bug yet, but we have the light installed, and we can turn on the machine just by plugging it in, and I'm going to show you that the solenoid activates when he plugs it in. Go ahead, plug it in. Okay, and when you unplug it, okay, so you saw earlier that I could turn on and off the light with my code, and you can see that now that the light is on, the solenoid driver's on. I am going to reload code right now that leaves the light off, and we will see if this solenoid does not activate. And once we know that, then we know that we can control the solenoid driver board, and all I have to do is get my software set up correctly. So I loaded up the code that turns the light bulb off, and the solenoid driver board, solenoid expander board, thank you, is no longer energized. So we now have control of that. So we're going to flip this back over and see how it's working. Hey, we didn't catch it on film, but we turned on the machine with the solenoid driver expander off, which is the way it's been working all previously, and of course it's still doing the same thing. And then we switched it and turned it on and reset the table, and when we did that, we got a reset over here, although the first time it reset, it only brought up 2 of them. The second time it brought up 3 of them. So there's some adjustment needed on that. But it didn't reset this one because that's reset in the off position of the relay expander. And in the on position, the thing did kick out the ball. However, we do still have the problem with a bad solenoid driver board. So the next thing I'm going to do is try and put a different solenoid driver board in there just to see if it fixes that problem. Okay, we put a spare solenoid driver board in, and it also had a stuck relay or stuck driver on it. So we pulled the new Altec board out of the 8-ball table. And Mike's going to order another one of these to fix our problem. But this solved the problem with this solenoid being jammed in. So yeah, solenoid driver board problem. Solenoid expander board is working, code's not. So that's something I will be looking at during the week. So pretty much that's all we got accomplished. It is time to quit for today. So this has been a lot of fun, and I'm glad we got that working. By the way, we did test out the kicker, and it does kick the ball out now. And the last time these reset, they did reset all of them, so those are probably just a little gummy from not having been used for a while. So yeah, it is coming along. We do still have the 8-ball single drop target to repair. It's got a broken part on it that we need to fix or put back together. So that'll probably be something we'll probably hit on next week. And of course, Mike's been here for 3 hours dawdling around stripping this table down, but he's almost there. So
I am there.
yeah. So anyway, thanks a lot for watching, guys. We'll see you next week. Again, it's Tuesday morning. I made another minor change to my code. I took out a 200 millisecond delay, which I almost never use delays in my program, and I'm not sure why I had stuck this in there, but I took it out. 200 milliseconds every time through the loop is going to basically delay most of the program time, and I think I might just be missing the relay resets. So I'm going to go ahead and log in and download my code, and I'll bring you back to see if this has fixed anything. Okay, the code has been uploaded, so I will power on the unit, and you and I can watch together to see what it does. And look at that. It worked. Everything reset. Nothing is out of whack. Start a game.
Chalk up.
So we still have a problem with this flipper.
7 ball. 6 ball. 5 ball. Ball Deluxe. 5 ball. Chalk up.
Okay, I set it to 2 players so I can test the resetting of the bumpers.
7 ball. 6 5 4 ball. 3 ball. 2 ball. Make the 1 ball. You've got the stripes. 14, 12, 11 ball, 10 ball, 9 ball. Sink the 15 ball. Make the 1 ball side pocket.
I'm hearing a funny clunk, but other than that, it looks like the stuff is working.
Shoot for 1 ball. 1 ball. Make the 8 ball.
Can't make the 8 ball.
Make the 15 ball.
All right.
Pocket.
This looks like it's working. So I gotta go. This is plenty good. We'll be back Monday to continue the operations. Thanks for watching, guys.